In this video, we show how to generate an executable counterexample using SeaHorn from a program that accesses to memory that is allocated by an external function. So in this program on the left, first we have a call to an external function that returns a pointer. This pointer is essentially a pointer to a struct that resembles a linked list with two integer fields, x and y. The first thing we do is to assume that the pointer is not null, and then we set the field p of y to 43, and then we have two consecutive tests. The first one is to check if p of x is 42, and the second one is p of y is 43. If both tests succeed, then there is an error. So here it's not difficult to see that in fact there is an error, since we set p of y to 43, so the inner test will succeed. And the first test will succeed also because it's not initialized in this program. So it may be initialized to 42 by the external function. So next, what we would like to do is to ask SeaHorn first if there is a counterexample, and if that's the case, we would like to generate an executable for that. So this is the command that we will execute. And now we need to add two options. The first one is for directed symbolic execution, and is to try to model the counterexample generated by the model checker using bit precision, and also try to be precise with memory, which means basically by adding extra assumptions, like for instance that each call to malloc has to allocate fresh memory, which is disjoint from previous allocations, or things like all the memory's addresses has to be 4-byte or 8-byte aligned, so on and so forth. And then the second option is for the external memory virtualization, and it says that it should generate physical memory on the fly for external pointers. So now we execute this command, and the first thing that we see is that it returns false, so there's a counterexample, and then it generates a file, so we check that the file is in fact an executable. So now what we can do, we just run the executable, and we see that there is an error. So SeaHorn actually print that verifier error was executed. So in order to get more information about it, what we can do is to run this executable through LDB. So we can set a breakpoint at main, and we just run the executable. So here we can see that actually verifier error is reached in this execution. So what we can do now, for instance, is to ask for the address of P. Now, this address is important to notice that this address is the address generated by the model checker. So it's a virtual address, so there is no allocated memory for it. So in fact, if we try to print P of X, basically, LDB will complain because it will say that it cannot read that memory. So what we can do is actually we can ask to the external memory virtualization component to give us the physical address that it has been generated for this virtual address. So what we do is to ask to the external memory virtualization to give us the physical address. And in that case now you see that we can actually see that the content of P of X is 42. We can also actually print the physical address directly. And in the same way we can actually print the content of P of Y. So with this we just reached the end of this video.